Hello, everybody, and welcome to our workshop. My name is Andreas Riehl, and I am the development architect in the ABAP platform. And with me today are Fischer from product management, who will lead you through the workshop later, as well as Niloofar Flothkoetter, also from product management, and Nausheen Minas from my development team, who will support with their analytics experience. I have the honor to give you an introduction on the topic, and I stand between you and the real fun today, which is then developing an end-to-end analytics scenario. I've just heard that it might not be completely possible because we do have now a broadcast session, but let's see then later on how we can deal with that. Okay, so what is the session with that bulky name all about? Create applications with SAP BTP, ABAP environment, and SAP Analytics Cloud. So SAP BTP ABAP environment tells us that we are developing on a steampunk system, which again means that we are using the RESTful ABAP development paradigm, RAP. RAP is commonly used to develop transactional applications. But as we want to develop for SAP Analytics Cloud today, we are focusing, of course, to analytics rather than on the transactional world. And in this introduction that I give you now, we want to understand what that means, what the differences are, and what SAP did so that we can nevertheless use the RAP development paradigm. We'll start with having a look at different types of applications and what their specific characteristics are. Okay, first, we have transactional applications, and they are typically used for daily tasks like applying for vacation, filing a travel expense report, or entering a sales order. These applications aim to be easy to use, have a static process, very low complexity, in order to be as straightforward as possible. And they process single data sets, so that means rows in the database, one at a time. And they are used to create, read, update, and delete data. So, of course, they are working on live data. Then we have simple analytical applications. These are for very quick and easy insights. And you know them from tiles on the S/4HANA Launchpad, from KPIs where they inform you on, let's say, leave days paid, active claim, or credit consumption. These applications are often static as well, and they only display very few data. Nevertheless, these applications are doing aggregations. So that means they are working on columns in the database. And the data they display may already be the result of one or even more quite complex requests. These applications are expected to display data immediately, but there's usually no need for them that the data is really 100% live. So they can be pre-calculated and can be refreshed in certain intervals usually. Then we have the full-fledged analytical applications that can, well, work on multiple dimensions at a time. And their purpose is that they can display complex situations, and not only display them, but they are interactive. So you can play with the data there. And the idea is that you can freely analyze really large volumes of data. But each interactions that you do in such an application may then really result in a very complex request and process lots of data. So these applications, you can imagine, are quite resource hungry. So and require different capabilities from the backend and the database. So yeah, but they only read data. So that's really a big difference. And that's the reason why they were classically working often with replicated data in dedicated systems. So took the data from, let's say, your S4HANA system, replicated it to a different analytical specific system where you could really work and play with the data. But with a database like HANA that is working in memory and is capable of processing column-based data and row-based data at the same time, it becomes now possible to support transactional and analytical scenarios on live data as well, same system. And this fact really opens the door for some new scenarios like embedded analytics. Embedded analytics means that we have a transactional application, but we have embedded analytical controls and embedded analytical capabilities that offer specific built-in insights. So the idea is kind of like in a computer game where you can see statistics on your health, strength, or your bank account on your heads-up display. But of course, there's much more to it. So maybe let's have a look at an example. What you can see here is not a real live example, but it's coming from a mock-up that we created when we first started the discussions about how or how embedded analytics will look like. And the idea of that Fiori application is quite simple. So we have a regular sales order, transactional UI, where you enter a sales order, and we have embedded analytical capabilities and controls in where you get an insight on the effect of what you're doing here in the sales order on your sales order volume and the credit consumption. That can be quite handy. Yeah, it's very basic. Like I said, it's a very early mockup, but it really gives us some fundamental requirements already. And yeah, let's have a look at those. So the most obvious one is, of course, the UI technology. So to be able to display analytical and transactional things on the same UI, of course, they need to be in the same UI technology. Straightforward. And the next thing is then the latency. So whenever the user changes the sales order, so in a way that it influences here the sales volume or the credit consumption, he wants to see that right away. So for sure, we don't have room here for long response times, and definitely we cannot present pre-calculated figures here. So that's 100% for sure. We need to work on live data, and that means we need to work on the same data. Apart from that, you quite quickly have the demand that you want to analyze further here. So these small analytical insights may not be enough. So you want to navigate away and analyze it further. And this requires a navigation into a separate external analysis tool, like, for example, SAC. But again, here, it's pretty obvious that we have to keep the context. And also, we have to work on the same live data. So it cannot be that we navigate away and then all of a sudden we're working on replicated data or on data that has a latency. So now let's see what these requirements do to our programming model. As you know, RAP is the programming model of choice for the transactional apps. So we need to make sure that it also satisfies the additional requirements for developing embedded analytics or analytics applications. So what we will do now is that we will take these development artifacts here on the right side, structure of a typical RESTful ABAP app, and check our requirements to the model against that, so that we can see what SAP had to do in order to make that work for analytics as well. And just like we would do when we develop for it, we will do that from bottom to top. So we'll start with the data model and work our way up then to the final application. Okay, so most important thing, the requirement for the live data. That makes it clear that the data must reside in the same system. I pointed that out already. And therefore, not only the data must reside there, but also the model definitions and the metadata will have to be in the same system as well. And that is no matter if we are here on the Fiori UI stack or if we are working with an external application. So I think that was the big challenge here, that we use the same model as well for the external applications. And now in order to consume the underlying models in the transactional as well as in the analytical world, of course, we have to use the same implementation concepts and make the same implementation concepts work, and the same implementation tools work as well for the analytics as for the transactional world. So ABAP CDS is the given language for all the modeling and the base views here, and for the whole transactional model as well. So we had to make it work for the analytical data model as well. That was not so difficult because we used it for SAP delivered analytical artifacts as well, but it was not fully available in Steampunk. So that had to be done. And then we had to make sure that the exposure here of the services also is working in the same way as for the transactional world, because the service, or the service exposure lies the basis for that we can use the analytical service in parallel to the transactional service, and then in the end really use it on the same UI. So it cannot be that the service exposure is working on a different in a different way. And apart from that, it makes it easier for the developer as well. So he has to learn the same concepts only once. Now coming to the UI, so to be able to do real embedding of analytical controls in a transactional Fiori app, we have to have UI5 controls available up here that can display analytical data and that are capable of doing analytical actions as well. So this is not yet fully the case. We will see that later on. We have such controls in place, but they are not available yet for the Steampunk developer. But what we do have is the external usage part. So what we will see today, the integration of SAP Analytics Cloud as the cloud analytics tool from SAP must be possible in a way that the live data in the Steampunk system can be analyzed in a performant way. And this can only be ensured, like I said, if the same models and metadata are used in the embedded analytical scenario as well, and if the communications happens over the same analytical protocol as we want to do it here on the embedded side as well. Okay, so far we learned what SAP has done in order to make the RAP programming model ready so that it can be used to develop analytical and embedded analytical applications in the same way as you're developing transactional applications. But how does that work in details? What are the differences that you have to keep in mind as a developer, and what do you really have to do as a developer? Let's have a look at that. So the requirements to the analytical applications that we talked about when we started on the first slide require really a different modeling. So why is that? In the transactional world, the models are optimized for accessing single data sets and for CRUD operations. And in analytics, we need to be able to aggregate large volumes of data in a timely manner. And therefore, the model must be built in a way that it can read the data as directly as possible without the need, like we have it in the transactional model, that we hop along associations across multiple views. So apart from that, the modeling must sometimes also be adapted in order to be able to leverage the full analytical potential of the database or the analytical backend. And the answer to that is a model that reads from the same basic interface views as the transactional one, but it is designed to analyze specific facts here. And what are facts? Facts are the measurable things that we are interested in. Facts are always somehow numeric, and they can be used for calculations and aggregations. This is why these fields are also called measures. So these could be prices, volumes, or counts. And in our example that we will do later on, we will analyze flight prices and booking numbers. Okay, but the facts that we have here only become interesting if they are set into a relation. And usually we set them into a relation with master data. For example, we will set the number of bookings in relations to the airline to find out how many bookings are done with each airline. Another relation might be the sum of all flight prices that are booked by an agency. And in analytics, we call the non-numerical fields that we aggregate by dimensions. So let's look at the model again. It looks like a star. So in the middle, we have the measures, and then these dimensions are grouped around them. This is therefore called the star schema. And how do we model that? So how do we model the cube? The center view is also called the fact view. It will then contain the measures, like we said, but also the keys of all the dimensions that we grouped around it. And we will also include 2-1 associations to the dimension views that are relevant for the facts as well. Like I said, the center view is called fact view or cube view in analytics. Technically, there is a slight difference between a cube view and a fact view, but this does not play a major role in our example. And it's also quite common that you do use cube views only and skip the fact views. Fact views are mainly important for replication. Okay, then again, looking at the dimensions, what do the dimensions bring? The dimensions are grouped, like I said, around the cube in facts, and they really bring the versatility to our model. So they bring attributes in that we can group by and that we can set our measures into relation. In our example, the dimensions are customers, airlines, travel agencies, or the connections with all their additional fields like destination carrier or airport. So what do we then do with the cube view and the query? So the cube view is finally consumed in a query, and an analytical query. And that analytical query is, so to say, the analytical consumption view. So its purpose is not to define the general analytics capabilities. That's what we do in the cube view. But it's designed with already a specific purpose in mind. It defines the initial layout that is displayed, selects the initial data, but it can also be used to calculate additional measures that are not present yet in our cube view. For example, we could set two measures in relation, like, for example, the average price per booking. And the query is the topmost development artifact in our model that is then also exposed as a service. And then later on, we see that in our front end and consume it there. Okay, this was on the model. Now let's have a look at the exposure side. We now expose the analytical query as a service so that it can be used by our clients. This could theoretically be done in the same way like we do it in the transactional world with an OData service. But then we wouldn't be able to really do all the analytical magic. So what we are doing here, we have the analytical INA protocol in place. And why do we want to use a different protocol? Because with that protocol, we can then leverage the full analytical potential as well as our analytical backend, but also of the database and the engines. So examples of the features that we do not have in the transactional world with OData and that we do have due to INA are that we have, for example, result set driven filtering. So we can do top-end filters by dynamically defined measures. Or we have relative input parameters like the last fiscal year. We have extended currency handling, extended unit handling. That means we could sum up different currencies. It's also not possible as easy in the transactional world. We can do dynamic aggregations, define intermediate results, do exception aggregations, and all that is due to the analytical engine very, very quick. And for the developer, the difference is really very easy. So the only thing the developer has to do is that he exposes his service not as in the transactional world with an OData UI, but with a service binding of type INA UI. We'll see that later on. Okay, then we have the client. So the client makes the largest difference between transactional and analytics. We've seen that already on the first slide. So to be able to operate all that analytical features, we need an according cockpit, so to say. In the web programming model, we typically have Fiori UIs or just an OData web API that can be used by different OData clients. In analytics, it's the same way. So we either have Fiori UIs then that are capable of communicating with INA and doing analytical actions, or we have that INA service exposed so that it can be used with an according client like SAC that is also able to speak the INA protocol and therefore can operate also with the same analytical capabilities. like I said before, we don't have the Fiori UIs in place yet. So they are in place, but they are used by SAP applications only so far, like the analytical queries that you know from SAP for HANA reports or KPIs, and they will become available to the Steampunk developers at a later point in time. Okay, but what we can do is that we can use already the external API, the external API, inner API. And this is what we are doing today. So let's have a look at the development flow that we will see now. And we will start with developing an analytical model, build several dimensions, a helper view as well, a cube view, and a query. And then we will expose the query in an inner service, make sure that it can be accessed. This is using the default wrap IAM app as well as the business catalog. And then finally, we will use SAC and build different beautiful visualizations on it. Okay, then I can hand over to Andre already so that we can start it with the hands-on experience. And yeah, happy coding. I will stay in the chat for questions. Thanks.
So I'm working here with two screens, so I hope you see that now. And I show quickly the same slide that Andreas showed here. That we will start here in the backend to create the different repository objects needed in order to build an analytical service. That means we would start to create dimensions and then a cube and a query. So for this, we switch to the Eclipse framework and if you look here on the right-hand side, there is a package that has been created, and when you would start this hands-on session, certain three-dimension CDS views would have already been created, and it would be your task here to create two others. And let me switch to the script. So the script is shown here. I just have to mention here that this session was supposed to run on a dedicated system, so not in an unlimited fashion. That means you can only run parts of the script in a trial system. That means the first part that I will show now, so creating a model using ABAP. But what's unfortunately not possible is the fun part, is the consumption of that service in an SAP Analytical Cloud system. So we have created here the script that describes all these steps step by step, and so you would start when you have connected to the system. You would for those that can do this, maybe we can do this later on for some of you. So you would receive a service key, and with using that service key, you would create a cloud project, an ABAP cloud project in ADT. In order to do that, you need the latest version of Eclipse and the latest version of the ADT tools. And then you can log on to the system And the first task that you would have to do is that you would have to import so-called templates. So in ADT, it is possible to create templates if you are creating, let's say, special kind of tables, or in this case, special kind of CDS views. It's possible to create here templates. Here, as you can see them, technically these are XML files. And if you open here in ABAP in Eclipse in the preferences, you can browse here for templates. And you see here there are data definition templates. And in addition to the templates that are delivered as part of the standard from SAP, you would find, after having imported these XML file, 3 new templates. And what are these templates about? So there is one template to create a so-called dimension. So a dimension view is a special kind of ABAP of CDS view. So it contains certain annotations, and we have added here in that template useful annotations that you would otherwise have to type yourself again and again. And then we have the same for query and for the cube. And we'll later show you quickly how that works. So I will walk you now through, let's say, you don't have to watch me typing each and every step. So I will walk you through the finished project. So that, let's stop this. So using this template, you create such CDS views, dimensions. So for example, I could create here a new one. I could create new data definition. And then I would enter here a name. That would be ZRAP 500. I customer. I customer, and then a new number. Let's say I will just choose an arbitrary number 701. Dimension for customer. And then the reference object is the table DMO customer. And if you press next, you are asked for transport request. You can press next again. And then it's important that you choose the correct template. In that case, we will choose a template for dimension. And if you press finish, you see that nearly the same happens here, but there are red marked sections in the code where you have to enter something. So in the template, you just found the string representative key, and the representative key is actually a field in that table. So if you press now Control space, you get a value help, and it will list you all the key fields. So it's a very simple table. There is just one key field, so we can just select the field customer ID, and then we can specify a so-called text element. And this is important for analytics because, let's say, the customer ID is just an ID, let's say a number 1, 2, 3, 4, 5, but usually humans are dealing with names. And here in that case, we would, let's say, like to see another value. Here you see I can't really choose it. I would have to edit first here because I would create a new nice property called customer name, which is a concatenation of the first name and the last name. And if I do so, I can then choose here from the list, and I could now choose the Where is my customer name? Here, customer name. And then we would have finished creating one dimension. So that's the first task. So you are creating, in addition for dimensions for customer, there is a dimension for connection, so for flights. Here you see we have two key fields, so we have to decide which one is the representative key of those. And so that would be the connection ID in that flight model. And again, we specify a text element for this key field, and that's the trip. And the trip is also a new field. That's a concatenation of the name of the airport ID to the airport ID. And if you press, for example, F8 now, we can do a preview. And here you see that the data and you see a nice list of readable representation of the trip that we would need for the analysis later on too. Then there is a dimension for carrier. So here it's a table carriers, so the different companies that are doing flights. So right now we know there are not so many flights because of the pandemic. And here we would see a list of flights. And what else do we have in the dimension? Then we have one dimension for agencies. And this is a reading from a table DMO agency. Okay, what's next? So we switch back here to the quickly to the presentation. So we have talked about dimensions, and then we want to create a cube. So the dimensions are used by the cube in order to get additional data. So looking at our model here, we have here a cube, right? This is define view entity iBooking cube, and it reads from an interface view. And this interface view we have created in addition. So actually we start with that, and this reads data from this booking CDS view. So this is a CDS view we have taken here from this flight model sample application, which this you can find in each trial system. So far everything what I show here can be done in the trial system, but if we reach the end of the demo, I will make clear what you can't unfortunately do. However, here you find an application, and there is and this we will use later on, because this is an app that is used for transactional processing, and with that we can later on create new travel data and add this data. But the data actually is stored in tables, and on top of this we have CDS views. And here you will find this CDS view that contains the booking data. And we press F8 again, we get a preview of this booking data that we are going to analyze. And going back now to our analytical model, we see here that the interface view for the booking is reading from that interface view from the transactional data, and we have enriched the data now a little bit. So we are adding here the semantic key for the agency ID, for which we have created dimension, and also for the travel ID. And we are adding the name of the person to the booking data who has changed this, because actually the name who has changed this is stored in the entity travel. So for each travel, there are several bookings, but we are enriching it so that we have it here also in our booking view. What else? Yeah, we are just adding here then associations so that they are published and can be used. And now we are creating the booking cube. So the cube is reading from this interface view that we have put in between, so between the transactional data and the and our analytical data. So we are actually here, right? So we are creating now the cube. So the cube is having associations to the different dimension views. And we find that there is always a foreign key association. So this way, the analytical model is able to retrieve data via the dimension CTS view. So here in the booking view, we just have the ID, but any other data that we might be interested in, that can then be retrieved via this foreign key relationships. Then we have here this a number 1 as total of bookings. So we have annotated this with the as being aggregated, and we are building a sum so that will give us the total number of bookings. And for this, we just added a field that contains a 1 so that it can be used to sum up the number of bookings we have. In addition, we have a second field that contains a so-called measure, so a measurable value. That's the flight price. So it's also annotated with these annotation that it can be a sum. And in addition, we have here an association to retrieve data via the customer country. And then after we have created the cube, the next step is to create the query. So we are now in our picture. We have reached this point here. So the query is reading the data from the cube. And let's look what we have here. And here, please note the naming convention. So while the cube is on the level of a so-called interface view, therefore it is denoted with an _i. The query is in the level of the projection layer, and for historic reasons, the projection views are denoted with a C, because in former times we called them consumption views. So therefore we use in SAP S/4HANA the naming convention, typically a namespace, then a Z or an I, depending on the role, and then some meaningful name. In that case, that's the booking query. Here we have annotated the different fields with analytical annotations, so that these data is shown either in rows or in columns. And in addition, we find the measures that means here the flight price. So the flight price, for the flight price, we do in addition a currency conversion, and we just take the number of bookings. So if we press F8, we also see some data. And okay, here I'm asked to authenticate myself. So if I press F8, that's a preview. It's a special kind of preview. It's similar to the preview you might know from the service binding for transactional data. And then you see this data as it is presented by the analytical engine. And here you see here now entries for the different regions. So unfortunately, I have a setting here a little bit in German. So Abfrage erneut ausführen means a rerun query. So this is a nice and helpful tool. So this is something that you would still be able to do in an ABAP environment trial system. So the preview you could run yourself there. And yeah, as I said, this happens if you press F8 or if you would choose here open with data preview. So that's the same what I did here. So now we have done all the development on this level here, where we created certain CDS views. So the next step is that we have to create a service definition. So the service definition is an object that is used to define which CDS views which are part of a model are being exposed. So here we just find the consumption view, so the projection view, the query, and this is then finally really published then. So though the preview works, right? So it's in the ABAP system itself, you won't be able to consume the service now. So for this, you would need a service binding, and this is then publishing the service. And in addition, you would have to create an IAM app in order to, this has some function like a role. So you add the service here to the, you could here add this service and maybe additional services by pressing here a button. You can choose a service type, and these can be different services. So not only analytical services, but here, but IAM apps are also used to publish or give access to OData v4 services or v2 services. And then these ERM apps are then assigned to so-called business catalogs. So that the business catalog has been prepared for you in this system. So all the apps that are actually publishing one analytical service of one group or one developer are all added here into one business catalog. Why? Because this is an administrative task, and so we won't let the developers even in a dedicated system give access to all the administrative functions. So we prepared a role, and we assigned that role to the developer himself. And by adding now the IAM app to that business catalog, the user will actually add this authorization to access this INA service from the outside world. Okay. So now we switch. Let's switch back to the script where we are. So we have walked. I've walked you basically through the script, and we did the following. So we talked about dimensions. So in the script you would create 2 dimensions because the data model is as such would be generated by a small a class that is already generating 3 dimensions. And this class is based on my open source project, the RUP generator. And then we have talked about the interface view and the cube. So that where we where we have created then a CDS view with the annotation analytics data category equal to cube. And here in this script, you will find all things step by step, how you can do that. And after having created the cube, we have talked about the query, and I've shown you the data preview. So it would now be time to switch to the next exercise. So that would be create and publish the analytical service. So the service definition I've shown you. So the service binding. Oh, I wanted just to show you again that this service binding is a special kind of service binding. So when you look here at the service binding of our service, you see that the binding type is INA UI. So if I would create a new service binding from that service definition, right, I would just RAP UI booking 701, right? So that would be service binding analytics. Then I'm able here to select different service binding. And one of them is now the INA protocol. So it's for information access, an abbreviation, but it's also possible to create other service bindings. It wouldn't make sense here now for that, but for transaction apps, you could, for example, bind to the OData version 2 protocol or to the OData version 4 protocol. Switching back to the script. So we have talked about the service definition and the service binding, and then I've shown you the ERM app that is being created, which provides access to the service, and this is then assigned to the business catalog. And after that, it's now time to consume that service with SAP Analytics Cloud. So we start now with logging on to SAP Analytics Cloud. So that would mean I would now connect to my to that system. So I've prepared this already. So that is here our that's here our Analytics Cloud system. A tenant, a special tenant for our demo. And let's start just by logging on once again to that box and see what happens. So I won't have now to authenticate because I have been authenticated in the other tab. And here it greets me with the username that I have. So it removes here the dash, so def 260-802, that's my user. And then you would the first task is to create a so-called data model. So you can create a data model here from data sources. Oh, I'm here. Sorry, I was wrong. I'm here in the modeler, and in that exercise, we are using a so-called live data model. So live means, and that's also what I'm going to show later on, is that I am able then to change the data, and then the data is immediate. The change to data is immediately visible in the charts, and that's a different. And that's the real difference between SAP Analytics Cloud and other tools that are out there to analyze data. So these are then downloading data from the SAP system. They are really exporting it, importing it into their system, and then doing some analysis, which is nice. However, this is not real-time data. And here we are dealing with real-time data. So we could create a new model. So that's of type SAP BW. And then there is a connection that has been prepared here beforehand. Again, that's an administrative task. You would set up a connection, and you have just seen this flickering, and that was the authentication. So it uses SAML-based authentication, and since the SAC system and the ABAP backend system are using the same identity provider, I'm automatically logged on, and now I'm able here to either choose from a list of services by pressing here this value L. And yeah, we could now search, for example, this number 48. That's the service that I created here beforehand. And then, no, I won't do that now because I created this already. So this is then the model that has been created. And this model, then you see here the measures and the dimensions. And interestingly, you see here that we are using GUIDs, and this is a nice thing. So this is influenced by an annotation. Let me check where it is. I think it's on cube level. No, I don't have it here. No, it's it's a session. Sorry, here it's this annotation. It's not by it's a setting, a general setting for the cube, and it means that internal name usage is switched on. And the advantage of that is, okay, here it looks yeah, the names are become GUIDs, and that way if you later on change your underlying model, let's say you are adding maybe an entity or something like that, then your model in SAC will not break, right? Okay, let's see. We are now in this model, and based on the model, go back to the script. After we have created such a model, so that this is explained here step by step. So this is what I showed you here. And this is a pop-up you would usually get if the systems are using different identity providers. And this is also the setting that is needed in the browser that this authentication is allowed. And then you are selecting the data source, as I said. And then the next step is to create a so-called story. And a story is where your data comes to life, actually. Here we are now, we will create a dashboard, and we will start to insert charts. And then first step, when you do it then the first time, you choose from the model and enter and add then this, let's say, chart or whatever to your story. Go back to, if we go back now to the browser, we see here in the, we see here this, this stories, welcome to stories. And you could either start here to create a new story, right? It would be Where's my here? That's the dashboard, and you would then start to let's say to add a chart, and then you select the model, and then you can move it here back and forth, and you are able, let's say, for example, to create a line-based analysis, and then you can select from the measures that are available. Let's say we will take the flight price, and we can add a dimension. So let's say we are analyzing the flight price by agency, so how much money we have spent for a certain agency, and that's, let's say, you see woman only has the most. Not sure why I would why is this now for travel, or here is hot socks travel and so on. And this is what I will show here in the other story. So in the one, so I will discard now the changes and go back to the story that I prepared. So here you find now the dashboard, how it should look like after you have gone here in the script through all the steps. So in the script, we describe here that we add certain charts, a table, do not chart, line chart, and one other line chart. Important is always that you save your data, because it's not automatically saved. So if you then leave the page, then you would have to redo what you did. So because it's then not saved. So we switch back to the browser where I have my story in. And let's now do something which would then be the last exercise. So what can we do here, for example? So let's have a closer look at happy hopping, right? Okay, we see here happy hopping as just bookings for $5,200, right? And we can now filter, and if we choose linked analysis for all widgets in the story, I can choose apply. Save my data. Remove that filter again, and then again do this filtering here for happy hopping. And then you will see that all my charts I have changed, right? So on the one hand, I see here now these travels, right? And I can see that that this travel here is it doesn't contain the number. Okay, we would now go to the backend and create additional bookings. So what I'm missing here is that in this list, okay, here, it's there, this low last changed by, so it has been done by 3, let's say, dummy users that we have created. And now we are going to create additional data for happy hopping. So that brings us to the last exercise. So last exercise is the one here where we where's my script? One moment. Where we test the live data connection. So I just showed this filtering in the story. And then it's the step where we change the data. And how do we do that? So here it's we use a nice feature. So I already showed you here okay, this is service binding for INA protocol. And now we are again going to this service binding for the travel data. And this is now the OData v4 UI for the transactional UI. And when we double click here on travel, it will start here to UI. Please note that I'm logged on with my user. So Andre Fischer is busy here. So we can create a new travel entry. So the agency we are going to select, and let's say we are searching for happy hopping. Okay, there is happy hopping and there's also happy holiday. And we can choose any customer. So we are not interested in that data. So we choose a start date and an end date. And let's say, oh, I would do now something wrong. So I would choose an end date, which is not after the starting date, right? If I would try now create, that won't work, right? So begin date must be after end date. So let's change this again. So we would have an end date of 1st of December. And now we are going to create bookings. And if you notice here in the apply button, every time I change something, there is a small pop-up, a small hint that draft data is saved. So we are using here the draft feature that allows us to maintain data, and it's automatically saved. And we could even leave now here the UI and come back later in 2 hours, and the data is still there. It's not gone. So even if the browser session has gone, the data would be still there. So we start, let's say, by choosing a flight number. Let's say choose an expensive flight. Here, the Alitalia, and you have noticed that lots of the flights that we have generated the data is just for United Airlines and Lufthansa. So if we would now add additional data, we would also see that we will get more bookings from Alitalia. So customer ID is also not that much relevant here in my demo. I would choose apply. I'm not sure why. And again, to make it even more expensive, I choose another flight here. From Lufthansa. Oh, I wanted to use again, maybe another flight from Alitalia, so that I also see that there are more flights from other customers. Okay, I choose that and choose apply again, and then choose create. And this has then created a new travel entry. And now we can navigate back to our analytical dashboard. And we see here that total of bookings is 100% for American Airlines. Okay, there are just 5 bookings. So we have limited the number of generated bookings such that you can actually see something. And if we now use a refresh here in the browser, we would actually see some data or some change in our data. Okay, first of all, here our The filtering has gone somehow, so not sure why with this happened. Okay, happy hopping. So now we see that 45% of our bookings is American Airlines, so that's not what I expected. Have I used the wrong one? No. Oh, you see, I chose the wrong agency. It was your choice. No. Now, happy hopping. First of all, we see that happy hopping is now. We see a spike here in our data, right? So before it was somewhere here, and now it is here. So if I'm now filtering the data, we see that American Airlines still has the majority of bookings, but now that Alitalia has 28% of the bookings, and in the data we also see that it is some other guy has changed this. So here it's not the text which is shown. This is something I could do. I could change here if I change the model a little bit. I could show the username, and yeah, we see that local changed by. Okay, here that this here is that the data has here been entered by def 20682. So here we see it. So in the some controls here from SAC, they are automatically reading the value from the property that has been denoted as a text, as containing the text to the key field. Okay, so this is now shown here, shown you here that we came here to the SAC story, right? So we had created a service binding and service definition, and we were able to visualize the data in SAC and consume our analytical query. And the cool thing is we are working on transactional data, which we can then manipulate also with RAP, in that case with the transactional processing. I guess that's what I was that's what I wanted to show. So summing it up, if you want to do these in the trial systems, you would be able to come up to here, exercise 2. Unfortunately, exercise 3 and 4 are not able, you will not be able to do that. This was because this session originally was filed as a session with limited seats, because the feature that we are going to show, that we are using here, is only available in licensed systems, and the trial systems do not allow you to create such connections. Yeah, that brings me now to the end of my demo.